So we are starting with the next module, which is called as Basic Principles of Flight. Okay, this is again one of the important module to understand how actually the drone is flying or how drone flies. Okay, so this is very important topic with respect to the technical aspect of drone flying or drone flying in the air. Okay, so basic principles of flight. So what are we going to learn in this particular module? It's the fundamental of flight, aerodynamics, takeoff of flight, flight and landing. Okay, then maneuvers, turn, circuit and patterns. Okay, so what are the fundamentals of flight? We have aerofoil, chord line, relative wind, center of pressure, angle of attack, angle of incidence, center of lift, center of gravity, and Bernoulli principles. So these are some important fundamentals for flight to understand. Okay, so when we see the aircraft, there are different components. Do you know what are the components of aircraft or aeroplane? Can you tell me some components of aircraft?
Engine,
Engine, okay. What else? External. Tell me about external.
propeller,
Propeller. I'm talking about aircraft, but aeroplane. I'm talking about aeroplane.
okay,
real या RC,
Whichever it is. Aeroplane, aeroplane है. RC हो या real हो, civil aeroplane. Components तो same रहेंगे ना, सिर्फ छोटा बड़ा रहेगा.
landing gear,
Okay.
Wings.
सबसे important क्या है? Wings. So wings
tail,
is the most important because that is what makes the aeroplane fly or glide, right? Tail and all these things are part of the aeroplane that also contribute to your flying or controlling your aircraft. So let's
elevator,
elevator,
radar,
radar, ailerons, all of
aero,
these things are there, right?
aileron,
Yeah. So let's see now what are the components. So when you see the cross sectional of the wing, आपने wing देखा रहेगा, right? Wing is there. So that cross sectional, अगर आप उसका cross sectional लोगे, you will see the cross sectional something like this. Okay. The upper one is the curved surface, below one surface is a plane surface. So airfoil is a cross sectional shape of the wing, blade of the propeller, rotor or turbine. Okay. So as of now, just don't worry about the blade, propeller, rotor or turbine. Just think about the wing. Okay, जो हमारा एरोप्लेन है उसका जो साइड से अगर आप देखोगे, the shape is something like this, right? It is something like this. The upper surface is the curved surface, whereas the below surface is a plane surface. So this is called as a airfoil section. Okay, so it has the front edge, जिसको बोलते हैं लीडिंग एज, और जहां पे दोनों सर्फेसेस एक जगह पे आके कनेक्ट हो जाते हैं, दैट सब पॉइंट इज कॉल्ड एज ट्रेलिंग एज. Okay, so leading edge is a bigger part, trailing is a sharper edge or a smaller part. Okay, whereas the chord line is nothing but the straight line intersecting the leading edge. यानी leading edge से trailing edge तक एक अगर line draw करते हैं हम लोग straight line, that line is called as chord line. Okay, now we'll see, understand what is the use of this chord line and what is this airfoil, how this defines the flying of the flight. Okay, so when the aeroplane is flying or it is running on the runway, okay, it is running in the opposite direction of the wind. Okay, so your relative wind is in this direction, whereas your flight path is in this direction. Okay, so if you see this way, you see the wing. Okay, the wing, the thing is, you can see here the wing, right? You can see the wing over here. This wing is actually showing you the cross sectional of the wing, okay, which we call as airfoil. Now if you see here the airfoil, the chord line is the line, straight line from the leading edge to the trailing edge. And if you see the relative wind, what it is flying, okay, the angle made between the chord line and the relative wind is called as angle of attack. So angle measured between the relative wind or the flight path and the chord of the airfoil is known as the angle of attack in aerodynamics. ओके, तो ये एंगल ऑफ अटैक आपका डिफाइन करता है आपका एरोप्लेन फ्लाई करेगा. ओके, अगर एंगल ऑफ अटैक ज्यादा हो जाता है तो क्या होगा? एनी आइडिया?
The plane will stall.
करेक्ट. सो योर प्लेन विल स्टॉल यानी कि गिर जाएगा. इट विल बी आउट ऑफ कंट्रोल. वो सीधा नीचे आ जाएगा. इट विल फॉल लाइक अ रॉक, डेड रॉक. ओके, सो
unstable fly,
अनस्टेबल हो जाएगा. यू नो समटाइम्स इट बिकम वेरी डिफिकल्ट. अगर आपका एरोप्लेन स्टॉल में चला गया है ना, तो उसको वापस कंट्रोल में लाना समटाइम्स इट्स वेरी वेरी डिफिकल्ट. आप कब कर सकते हो उसको कंट्रोल? जब आप बहुत पावर दे रहे हो. फॉर एग्जाम्पल जैसे आपने देखा रहेगा मिलिट्री के एयरक्राफ्ट जो रहते हैं, फाइटर प्लेन्स जो रहते हैं, वो कैसे भी फ्लाई करते हैं, उल्टा सुल्टा, ऊपर नीचे, ऑल दिन. क्यों? क्योंकि उसका जो जेट इंजन रहता है ना, वो बहुत पावरफुल रहता है कंपेयर टू दी एयरक्राफ्ट. एयरक्राफ्ट के माने में उसका जो इंजन है वो बहुत पावरफुल है, तो इंजन उसको कंट्रोल कर सकता है. वो मतलब इट्स लाइक वर्टिकली सीधा फ्लाई करता है. आपने देखा रहेगा एरो जो फाइटर प्लेन्स रहते हैं वो वर्टिकली सीधा ऊपर चला जाता है, राइट?
Yes,
आपका
F-22.
कमर्शियल एरोप्लेन वैसे नहीं फ्लाई कर सकते. कमर्शियल फ्लाइंग वैसे कर ही नहीं सकता, क्योंकि वो इंजन इतने पावरफुल नहीं है कि वो उतना पूरा एरोप्लेन को वर्टिकली ऊपर लेके जावे. ओके, क्योंकि वो वेट, कंसिडरिंग द वेट साइज ऑफ द सिविल एरोप्लेन, द इंजिन्स आर नॉट दैट पावरफुल. दोज इंजिन्स आर ओनली सफिशिएंट फॉर फ्लाइंग, नॉट फॉर डूइंग मैन्यूअर्स. यू नो जो एरो एक्रोबैटिक्स मैन्यूअर्स जो करते हैं फ्लाइटर प्लेन्स, दैट कैन नॉट बी डन बाय योर सिविल एयरलाइंस और सिविल एरोप्लेन्स. ओके, सो वो डिफाइन करता है एंगल ऑफ अटैक. तो एंगल ऑफ अटैक जितना मिनिमम रहेगा उतना आपके लिए अच्छा है. बहुत ज्यादा भी नहीं हो सकता है, बहुत कम भी नहीं हो सकता. अगर कम होगा तो आपका एरोप्लेन फ्लाई नहीं करेगा. तो देयर हैज टू बी सम डिग्री which is called as angle of attack. अगर आप बहुत ज्यादा करोगे तो आपका एरोप्लेन स्टॉल होगा. Now what is angle of incidence? Now angle of incidence is a fixed angle. Okay, it cannot be changed. Now angle of incidence is nothing but it's an angle between the chord line. जो आपका विंग है, विंग का जो आपका लीडिंग एज एंड ट्रेलिंग एज ज्वाइन करने के बाद जो chord line बनता है, and the longitudinal axis of your aeroplane from your tip of the aeroplane till the tail of the aeroplane, that is your longitudinal axis. इसके बीच में जो एंगल बनता है वो है एंगल ऑफ इंसिडेंस. ओके, इट इज द एंगल बिटवीन द कॉर्ड ऑफ एरोप्लेन एंड लॉन्जिट्यूडनस ऑफ द एयरक्राफ्ट. इट कैन नॉट बी चेंज बाय द पायलट, क्योंकि ये जब आप एरोप्लेन डिजाइन करते हो तभी ये बनाया जाता है. दैट इज व्हेन द डिजाइनर डिजाइन्स फॉर. सो एंगल ऑफ इंसिडेंस विल वेरी, बट इट कैन नॉट बी चेंज्ड of any aeroplane as on it's required. It is a fixed for that particular aeroplane. Okay, any questions so far?
No.
Right, you are clear on the relative wind, angle of attack, even the last two definitions of aerofoil and chord line. These are very important because we'll be talking on these lines again and again in different slides. Okay, so airfoil आपको समझ में आ गया. Okay, chord line you got it. So airfoil, again I am repeating, it is the cross section shape of the wing, blade of the rotor or turbine. Okay, as of now you just consider the wing of the aeroplane, उसका cross sectional view है. Okay, it has a leading edge. The bigger surface or the larger surface area is called leading edge. Top surface is a larger area, below surface is the smaller area. Okay, if you see where the tip joins of both the surfaces is called trailing edge. If you draw a straight line from trailing edge to the leading edge, it will be called as a chord line. Okay, chord line will define the angle of attack with respect to the relative wind. Again, the chord line will define the angle of incidence with respect to the longitudinal axis of the aeroplane or aircraft. Okay, so what are the forces on the flight? When we are flying the aeroplane, what are the forces affecting on it? One is the force because of the weight. Every aeroplane will have its own weight, so that weight will always try to pull down. So gravity will affect on the aeroplane, and aeroplane will always try to come down or towards the earth. Okay, what will counteract it? Will the lift. So lift will counteract the weight, so it will try to go out. Now since aeroplane is a structure, it's a body, okay, so there will be a friction, air is flowing around it, so there will be a friction, so that drag will be there. How do we overcome the drag? By giving thrust, यानी पावर. हम लोग अगर कार को पावर देते हैं, एक्सीलरेटर दबाते हैं, तभी तो आगे जाती है ना, नहीं तो अपने आप तो गाड़ी आगे नहीं जाती है. तो देयर विल बी ऑलवेज अ ड्रैग. तो अभी हम लोग कितना फास्ट भगाते हैं गाड़ी को, कार को जितना ड्राइव कराते हैं, एक्सीलरेटर देते हैं, उतना फास्ट भागती है. बट देन इट इज काउंटर एक्टिंग द ड्रैग, क्योंकि उसके ऊपर एयर फ्रिक्शन हो रहा है, एयर का फ्रिक्शन हो रहा है. इट इज ट्राइंग टू स्टॉप द व्हीकल. ओके, that is called as drag force. Okay, तो हम लोग जब कार डिजाइन करते हैं तो क्या करते हैं हम लोग, आपने देखा रहेगा कार का डिजाइन इज ऑल्सो समवॉट लाइक दिस ओनली, राइट? हमारा फ्रंट इंजन का पार्ट रहता है थोड़ा कर्व्ड रहता है, देन बीच में हम लोग जहाँ बैठते हैं वहां पे ऐसे रहता है, देन बैक साइड हमारा वापस टेपर होता है या थोड़ा सा ओपन रखते हैं, क्योंकि हमें हमें तो कार को फ्लाई नहीं करना है ना, बट एरोप्लेन को फ्लाई करना है, तो एरोप्लेन का शेप वैसे ही है, देखो आप देखोगे तो लाइक कार ओनली, बट देन अगेन बैक साइड इट बिकमिंग टेपर. ओके, बीच में हमारा बड़ा पार्ट है. So the lift will lift the aeroplane up in the air, gravity will try to pull it down, drag will try to hold the aeroplane back, thrust will move the aeroplane in forward direction. So these are the forces of flight. Okay, so what is the principle of flight on which works? So अगर आप imagine करो, air is nothing but it's like a fluid. Okay, air is nothing but it's a fluid only. Okay, in physics a fluid is a substance that continually deforms when external force is applied. Fluid includes liquid, gases and plasma. Okay, तो फ्लूइड इंक्लूड्स लिक्विड, गैसेस एंड प्लाज्मा. अगर आपने देखा रहेगा आपका किचन में जो वॉश बेसिन में या फिर किचन सिंक में जो वाटर टैप है उसको आप चालू करते हो तो वाटर विल फ्लो स्ट्रेट. उसके आगे अगर आपने ऐसे स्पून लगाया तो द वाटर विल नॉट स्टॉप ओवर देयर, राइट? वाटर विल टेक द शेप ऑफ द स्पून एंड ट्राई टू डाइवर्ट इट्स flow, right? It will take the shape of the spoon. This effect is called as Konda effect. So same is applicable when the air is flowing on the surface of the aircraft or on the wing. It will try to take the shape of the wing. Okay, now how that shape will affect the flying, that's we'll see. Okay, so lift, again we talk about the lift. Lift is perpendicular to direction of motion, difference in pressure, whereas weight is always downward, that is called gravity. Because of the gravity the weight will always force downward. Drag is opposite to the direction of motion. Friction and difference in the pressure will cause drag on the body. Okay, so these are the three things which will cover, forces which will affect your motion of the aeroplane as well as flying of the aeroplane. So now the important principle on which actually your aircraft flies. Okay, here I am just put the text. Okay, next slide will show you in a diagrammatic way, but let's first read the principle. The air is separated at the leading edge. So when the air hits the leading edge, the air gets separated of the airfoil and rejoins at the trailing edge. यानी कि आपका air जो आता है वो आपका लीडिंग एज पे सेपरेट होता है. सो सम एयर विल फ्लो ऑन द टॉप ऑफ द एयरफॉइल, सम एयर विल फ्लो बिलो द एयरफॉइल एंड देन इट विल जॉइन अगेन बैक एट द ट्रेलिंग एज. द एयर हैज टू मूव फास्टर ऑन द अपर सरफेस, क्योंकि ऊपर के सरफेस पे कवर्ड है ना, कर्व्ड सरफेस है, तो कर्व्ड सरफेस पे इट हैज टू मूव फास्टर टू कवर द डिस्टेंस. So air flowing on the upper surface of the wing has more velocity than the air flowing below the wing. Okay, this principle states that increase in the speed of air occurs simultaneously with the decrease in the pressure. Yani what is it trying to say? That as the upper surface the air is flowing with high velocity, there is a low pressure created. Similarly, below the surface or below side, the air is flowing at a low velocity, so the high pressure is created below the wing. So when the aircraft is flying, what happens? So if you see the structure like this, okay, the air which is flowing on the top part is flowing at high velocity, but the pressure is low over here. But the air flow which is flowing below, it has to cover the less distance. The velocity is low, but high pressure is created. So what happens? Your wing will try to flow upwards or cause the upward movement. Okay, the upward lift. That is what it's trying to say. This is what we call it as a Bernoulli principle. Let's see in the next slide. So here again you can see the air flow, high velocity so it gets separated at this leading edge. Okay, it flows up. The red one is the high velocity of air, so low pressure is created over here, whereas the blue line you can see, which is a low velocity airflow, this will create high pressure below the wing. Okay, and this difference in the pressure will create lift in the aircraft. Okay, so lift is due to the pressure difference. So there is a difference. So high pressure नीचे generate होता है, तो it will try to take the wing upward. Okay, So that is what it is shown in this diagram. So are you clear on this Bernoulli principle? This is the most important principle on which your aircraft flies.
Yes.
Okay. Now, apart from Bernoulli principle, there are three rules which we need to know. That is called as Newton's law of motion. Do you remember what are Newton's law of motions? Any idea? याद है आपने पढ़ा रहेगा 10th में 11th में 12th में कभी ना कभी तो पढ़ा होगा राइट न्यूटन्स लॉ ऑफ मोशंस so there are three laws okay first law talks about inertia that means what it will say that any object which is at rest will always be at rest which object is in motion will always be in motion until unless the external force is applied on it. Second law says that the motion will be there continuously until unless there is a additional force is applied on it until unless that change will not happen. So that force is equal to mass into acceleration. And third law says that every action there is a equal and opposite reaction. यानी कि अगर आप ड्रोन को फ्लाई करना चाहते हो तो इट हैज टू गिव अ प्रेशर और रॉकेट को फ्लाई करना है तो रॉकेट हैज टू जनरेट द थ्रस्ट राइट देयर इज अ गैसेस व्हिच आर गेटिंग pulled out from the below part of the rocket. Okay, so Newton's first law states that if body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at a constant speed unless it is acted upon by a force. The ball will be stationary if it is stationary. Ball will be in motion, will continue to be in motion until unless there is any force effect on it. Like you kick the ball, like you are standing in a ground, you kick the ball, you applied the pressure, the ball will start motion, but it stops after some times. Why does it stops?
Friction with the ground.
Correct, friction with the ground as well as air. अगर आपने एयर में भी किक किया तो क्या होता है बॉल ऊपर तक जाता है and then because of the gravity it comes down. It cannot go. So you need to apply such a pressure that it goes beyond those pressure or those effect. अगर मैं बॉल को इतना जोर से पुश करूंगा इन द एयर दैट इट विल एस्केप द अर्थ ग्रेविटी देन इट विल कंटिन्यूली रिवॉल्व अराउंड द अर्थ सो दैट मोशन विल कंटिन्यूअस ओके बट उतना मेरे को प्रेशर जनरेट करने को होना चाहिए आई कैन नॉट किक बॉल दैट फास्ट राइट दैट्स व्हाई व्हाटएवर द ऑब्जेक्ट्स वी नीड टू सेंड इनटू द स्पेस व्हाट वी डू वी अप्लाई रॉकेट्स राइट वी डू put those spacecrafts or satellites into the rocket and then send them out of the earth's gravity, right? We make them fly such a high and away from the earth so that earth gravity is not affecting the motion of it and it continuously revolving around the or orbiting around the earth, or maybe it can go outside the earth effect also, earth gravity effect also, like if you're sending a satellite or a spacecraft to let's say moon or Mars and all that thing. So that much power I am applying to it. So that's the Newton first law of motion. Second law says it's a quantitative description change of the force. Like if the particular object, like for example, I send a satellite, but I want after some time, like you might have seen Chandrayaan or Chandrayaan 3 motions, like initially that aircraft was rotating around the earth, and after some time they give some thrust, and then it goes into the lunar orbit or lunar and all that, or goes towards the first lunar, and then it is captured by the lunar gravity, and then it keeps start rotating around the moon, and then after some time again they give some so there are small tiny rockets or rocket engines are there which actually gives the thrust, and that thrust gives you the motions or the direction what is required. So that direction or that thrust, whatever we are saying, that force is equal to mass into acceleration. So whatever the mass is of your aircraft plus whatever the acceleration you give it to that mass, that will equal to your force. Okay, अगर आपका acceleration कम है तो आपका spacecraft जगह से हिलेगा भी नहीं. Okay, it will keep on rotating in that orbit only. So if you want to move out from that orbit, that much thrust you need to generate or that much force you need to give to that aircraft. Okay, so that's the Newton's second law of motion. Third law is the most important part because on which your drone actually flies. Okay, so एक तो principles of Bernoulli principles हमने देखा, and Newton's third law which is applicable to our drone. So what happens here is say that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. So if you see the example of rocket is as on now, imagine it is on the launch pad. So it is just on launch pad. Does it move on its own? No, because there is no force applying. There is only one force which is applied on the rocket is gravity. That's the weight of the rocket. It is moving it down. Now, if it was to go up, what it needs to do is it needs to fire the engine, right? It has to fire the rocket. So rocket will start burning, the fuel will start burning and create a hot gas which will come out from that nozzle, and it will start pushing the ground. But can rocket move the ground? No, right? Because it doesn't have that much thrust that it will move the earth. Earth cannot be moved because itna thrust to nahi hai. But then it has that much thrust where it can move its own. So rocket will start climbing from its launch pad. You might have seen when the rockets are launched by NASA, ISRO, or any space organization, it will start burning. Initially, they show that burning is there, and then they increase the thrust of that rocket. As it increases thrust, the rocket start climbing. So what is happening actually? It is actually pushing the ground. But since it cannot push the ground, it will start rise up in the sky. It will go up and then it will go into the space. Similarly, when you are flying the drone, when you give the throttle to the drone will start climbing little bit high up in the sky. But you want to go up, you have to keep on giving throttle. That means your rotors needs to be rotating very fast. So it has to push the ground and come up. Okay, so at certain extent only, since as it goes up in the air, it needs to push. So drone cannot go. See, that's why drone are not good enough to fly in a higher altitudes, because it cannot push anything below the ground. Ground is very far from the drone where it is. So drone का भी limit रहता है, certain limit it can go and then it cannot go further up. Then it requires lot of pressure to come up and fly up in the air. So that's why drone also has its own limitation on what extent it can fly. That's why for higher altitude you are using what? A aeroplane, not the rotorcraft drones. Okay, for a higher altitude you are using aeroplane model type of drones. Okay, so that where you can fly and take them at a high altitude, because there is where you are actually flying with the air. You're taking the guidance of the air. Whereas in a normal scenario, when your rotorcraft is flying closer to the ground, it is nothing but it is trying to push the air down. Okay, so that Newton's third law of motion is applicable to it. But as it climbs up and up and up, it cannot climb to a very high extent. There is certain limitation is there to the drone on which it can go up. Okay, so that's how the Newton's third law is applicable for your drone flying. Clear on this principle? So there are only two principles on which your drone or rotorcraft is flying. First one is the Bernoulli principle, and second is the Newton's third law of motion. Okay, then center of lift and center of gravity. Center of gravity is nothing but the center point of the aircraft where the aircraft balances on its own. Whereas center of the lift is nothing but it's the center of pressure, or the where all the axis joins to each other. Now, if you see the aircraft, I think Umesh can answer this question. Like when you make a aero model of an aircraft, where is your center of gravity? And why do we make the center of gravity further to the center of lift? Any idea do you have? And what is the word or terminology called for that? That where we are defining the center of gravity to be little bit ahead of center of lift. Any idea? Umesh,
Uh,
have you seen this? Why do we define center of gravity further to the center of lift? सेम रहेगा तो कोई फर्क नहीं पड़ता है, बट देन यू विल नॉट हैव अ एयरक्राफ्ट फ्लाइंग एफिशिएंटली. नॉर्मली व्हेनेवर वी आर फ्लाइंग, व्हाई वी आर मेकिंग सेंटर ऑफ ग्रेविटी अहेड, सो दैट द नोज will be little bit heavier compared to the entire body. Okay, so you are not balancing your aircraft at the center of lift. You are little bit making aeroplane heavier in the front, so that you can make nose up when you are pitching up the aeroplane. Okay,
yes. Hmm.
तो आपको हमेशा नोज अप करना पड़ेगा, तब आपको एरोप्लेन का फ्लाइंग एफिशिएंसी मिलेगा. ओके नहीं तो क्या हो-
this elevator.
हाँ, सो एलिवेटर
हाँ,
विल एक्चुअली मेक योर
elevator
पिच
अप होतो
करेगा
तेव्हा एलिव्हेटर अप होतो तेव्हा प्लेन फ्लाय होतं आणि डाऊन गेलं का लँड होतं.
लँड होता.
आणि
करेक्ट.
आणि ॲलिरॉन लेफ्ट आणि राईट मूव्ह होण्यासाठी आणि
विल कम
रडार
टू
असतो
दॅट.
तो स्टेबल.
Correct. We'll come to that. So center of lift, the average of the lift forces through which all the lift is considered to be acting same as the center of pressure. Okay. Whereas center of gravity, normally always you see here, जो center of lift है उससे हमेशा आगे रहेगा. So means your nose is always heavier. So whenever you are doing even rockets, अब देखो rocket जब रहता है तो क्या होता है? Rocket आप पूरा देखोगे, there are multi-stage rockets, right? So as rockets is flying, उसका body का certain parts निकल जाता है, like first stage will get descentable, but still the rocket is heavy because last part में ही आपका top part में nose में ही आप क्या रखते हो, आपका satellites रखते हो, आपका payload जो भी आपको launch करना है वो सबसे top में रखते हो. So you are making your rocket heavy. जैसे आपका रॉकेट फ्लाई करता रहता है, उसका फ्यूल बंद होता रहता है, नीचे के स्टेज लाइटर होते जाते हैं, राइट? दे आर लाइटर, सो दे आर डिसअसेंबल्ड. ओके, दे आर डीएक्टिवेटेड फ्रॉम द बॉडी इटसेल्फ. फिर सेकंड स्टेज चालू होएगा, फिर सेकंड स्टेज बर्न होके कंप्लीट होएगा, अगेन सेकंड स्टेज विल गेट डिसेंबल, देन थर्ड स्टेज, देन फोर्थ स्टेज, like that it will happen. So but still your weight is at the top part, so you will always make your nose heavy. Okay, so your center of gravity is always ahead of the center part. तो रॉकेट भी जब डिजाइन करते हो तो आप ये पॉइंट आपको कंसीडर करना है कि फोर्थ स्टेज में भी मेरा वेट ऑफ द और द सेंटर ऑफ द ग्रेविटी इज ऑलवेज अहेड ऑफ द सेंटर ऑफ लिफ्ट. So aerodynamics is the study of how gases interact with the moving bodies. Engineer applies the principle of aerodynamics to the design of many different things, even buildings, bridges. So आप जब भी आप bridges डिजाइन करते हो, जब भी बड़े बड़े buildings जैसे बुर्ज खलीफा है या big towers which you design, they are all are designed considering the aerodynamics because there will be a huge air which will be flowing around the buildings. Okay. The primary concern of aerodynamics are aircrafts and automobiles. Even आपकी जो automobiles है, cars है, right? Innova car जैसे देखो आप या फिर any car you see, they are always designed aerodynamically because they are also riding or driving on the road. वहाँ पे भी आपका air effect करता है आपका कार के ऊपर भी. So your cars or aircraft they also needs to be aerodynamically designed. So aerodynamics comes into the play in the study of flight and the science of building and operating an aircraft which is called as aeronautics. So जो study हम लोग करते हैं flights का and building के लिए, तो that is what is called as aeronautics. तो हम लोग बोलते हैं ना aeronautical engineering कर रहे हैं या aerodynamics सीख रहे हैं, so that is what is the study of flight and the science of building and operating of aircraft. Okay, so let's see now what are the control surface. There are two types of control surfaces on aeroplane. The first one is called primary control surfaces. So if you see on the wing, you will see the primary control surfaces are ailerons. Okay, so you have ailerons. These are the primary controls. Even spoilers are also there, but spoilers and flaps are used for different purposes. The main purpose of the air flight control is ailerons on the wings. Whereas on the your horizontal and vertical stabilizers, you have on horizontal stabilizers you have elevators, whereas on the vertical stabilizer you have radars. Okay, so these three controls, forget about as of now spoilers, flaps, slats and all these things. Okay, these are always available only in the bigger aeroplanes like your Boeing aeroplanes, Airbus aeroplanes. But अगर छोटा aeroplane है, Cessna, ओके, सेस्ना 180 या सेस्ना 150 सीरीज वाला जो एरोप्लेन है, उनके ऊपर ये सब चीजें नहीं रहेंगी. उसके ऊपर सिर्फ रहेंगे तीन चीजें, एरोलॉन्स, एलिवेटर्स एंड रडार्स. और इवन इफ यू सी द एरोप्लेन विच आर फ्लोन ड्यूरिंग वर्ल्ड वॉर 1 एंड वर्ल्ड वॉर 2, you will only see these three types of control surfaces, okay, or controls. What is ailerons, elevators and radars. Now let's see how these three controls the flying of the aeroplane. Okay, so what does aileron does? Aileron does nothing but it does the roll motions, and that roll motion happens on what? The longitudinal. What is the longitudinal axis? From the tip of the aeroplane to the tail of the axis. So what is the longitudinal? आपका समझो एरोप्लेन ऐसे है, ऐसे फ्लाई हो रहा है, तो आप रोल कर रहे हो तो क्या कर रहे हो? सी दिस इज इंपॉर्टेंट. ओके, दिस विल बी इंपॉर्टेंट व्हेन यू आर फ्लाइंग द ड्रोन आल्सो. तो आप रोल कर रहे हो तो क्या कर रहे हो, यू आर जस्ट मूविंग अ लैटरल मूवमेंट on your lagittal axis. Okay, you are doing lateral movement. Okay, you are seeing my hand, right? So this is your roll motions. So you are rolling. Okay, so this is roll right, this is roll left, roll right, roll left. Whereas when you see radar is what? It's a tail. Okay, tail पे है आपके पीछे. तो रडार के मूवमेंट्स करते हो तो क्या होता है, आपका डायरेक्शन चेंज होता है. ओके, हेडिंग चेंज होता है. तो दिस इज व्हाट यॉ, दिस इज यॉ मोशंस. ओके, दिस इज यॉ मोशन. हमने पहले एयरलॉन से क्या देखा, रोल. अभी क्या देख रहे हैं, यॉ मोशन. सो यॉ मोशन इज चेंजिंग द डायरेक्शन लेफ्ट एंड राइट. ओके, सो राइट लेफ्ट, ये ऐसे. अभी जैसे मैं ड्रोन फ्लाई कर रहा हूँ ऐसे, योर राइट, सो यू हैव टू मूव योर ड्रोन लाइक दिस. योर लेफ्ट, योर ड्रोन लाइक दिस. ओके, सो दिस इज द मूवमेंट. वेयर एज एलिवेटर क्या करता है, पिच करता है आपको. पिच मतलब क्या होता है, अप. इधर गो अप और इट विल पिच डाउन. ओके, सो डिपेंडिंग अपॉन एलिवर, जो आपका पीछे का जो हॉरिजॉन्टल स्टेबलाइजर है उसका कंट्रोल से आपका पिचिंग हो जाए. नाउ इन ड्रोन दिस कॉन्सेप्ट इज लिटिल बिट ट्रिकी एंड डिफरेंट. नाउ ड्रोन में क्या है, 4 ऑप्शंस होते हैं. ये आपका रोल तो हो गया, रोल इज राइट एंड लेफ्ट. यॉ हो गया. अभी पिच इज व्हाट, पिच इज फॉरवर्ड मोशन. बिकॉज ड्रोन व्हाट इज डूइंग, ड्रोन इज एट अ स्टेबल पोर्शन, स्टेबल लोकेशन, राइट. हॉवरिंग हो रहा है आपका या लॉइटरिंग हो रहा है एक जगह पे. आप पिच बोलते हो तो क्या होता है, पिच फॉरवर्ड, पिच बैक, पिच फॉरवर्ड, pitch back. That means you are moving forward or you are coming back. Okay, so in aeroplane you do not have pitch back. There is no pitch back motion. Aeroplane is always moving forward location, forward, हमेशा forward है. अब pitch देते हो तो क्या होता है, हाइट रेज होगा. पिच डाउन करोगे तो क्या होगा, नीचे जाएगा. ओके, सो दिस इज द मोशन. वेयरएज इन ड्रोन एज आई सेड, पिच फॉरवर्ड, पिच बैक. लेकिन ड्रोन में और एक मोशन है विच इज कॉल्ड एज थ्रॉटल. थ्रॉटल में क्या होता है, आपका हाइट चेंज होता है, एल्टीट्यूड. तो वेरेवर यू आर देयर द ड्रोन विल गेन द हाइट. और थ्रॉटल डाउन करोगे तो आप नीचे आओगे और यू विल लैंड योर ड्रोन. तो व्हेन यू आर टेकिंग ऑफ यू से थ्रॉटल अप, थ्रॉटल अप, थ्रॉटल अप, थ्रॉटल दो, थ्रॉटल दो. यू नो, यू विल ऑलवेज से थ्रॉटल अप. Pitch is nothing but moving forward or moving backward. Pitch back, pitch forward. Roll right, roll left. Your right, your left. Clear? So ailerons in aeroplane are responsible for rolled motion. It is happening on the longitudinal axis and the motion is in lateral form. Elevators are nothing but they are for pitch motions. Okay, they are lateral and affects on the longitudinal part. Okay. Whereas radar is affecting the yaw motion or heading motion. Okay, so normally हम लोग एरोप्लेन में या फिर ड्रोन में रोल मोशन कम यूज करते हैं. बिकॉज रोल क्या होता है, आपका ड्रोन का ओरिएंटेशन चेंज होता है. ओके, ओरिएंटेशन चेंज होता है रोल. सो वी ट्राई टू अवॉइड, एज इवन एरोप्लेन में आप रोल ज्यादा यूज नहीं करते हो. ओके, नॉर्मली यू विल से पिच अप, पिच डाउन और यू विल डू यॉ. सो यॉ. ओके, कभी कभी आप रोल और यॉ यूज करके डायरेक्शन चेंज करते हो एरोप्लेन में. ओके, बट यू विल ट्राई टू अवॉइड एज मच एज रोल मोशंस. ओके, रोल मोशन आर वेरी लेस. जब आपके कोई कंट्रोल सरफेस में कोई प्रॉब्लम है या कुछ प्रॉब्लम्स आ गए तभी आप रोल मोशंस यूज करते हो, बट रोल मोशंस आर वेरी लेस यूज्ड. आर वी क्लियर ऑन द एक्सिस ऑफ फ्लाइट?
Yes.
Okay, so understand roll, pitch and yaw.
Yes.
Okay, so now what is takeoff, what is flight and what is landing? So we'll talk more about roll, pitch, yaw in subsequent slides also. You know, ये बार बार topic आता रहेगा. You know, there are certain concepts needs to be talked more and more and more. So different points will come up as we progress the training. Okay, so takeoff, it is the phase of flight in which aircraft goes through the transition from moving along the ground to the flying in the air. So when we so we as of now we are only talking about aerodynamics or aeroplane. Okay, so takeoff क्या होता है, आपका एरोप्लेन रनवे पे रन कर रहा है, इट इज मूविंग फॉरवर्ड एंड इट ट्रांजिशन. दैट मीन्स क्या होता है, आप एक एंगल देते हो, आप एंगल चेंज करते हो. जो आपका एरोलॉन्स है और आपका स्टेबिलाईजर है, राइट, हॉरिजॉन्टल स्टेबिलाईजर, एलिवेटर्स, आप उनको कंट्रोल करके आप क्या करते हो, टेक ऑफ लेते हो. दैट टेक ऑफ, यू नो, दैट एंगल यू आर क्रिएटिंग, एंगल ऑफ अटैक जो बोल रहे थे ना हम लोग. सो एंगल ऑफ अटैक, फॉर एग्जाम्पल मैं देता हूँ, आप ड्राइव कर रहे हो कार, अब सडनली आपका टेक योर हैंड आउटसाइड द विंडो ऑफ योर कार, होल्ड इट पैरेलली टू द ग्राउंड, व्हाट हैपेंस? You can feel the air pressure, right? You are driving at almost 80 kilometer per hour speed, and that hand what you have taken outside your car window, just give a little bit tilt. What do you feel? Do you feel any difference from earlier action to the now action?
Yes, sir.
What difference do you see? What
Difference in pressure.
you will see the difference in the pressure, and your hand will try to raise up. If you hold a hand parallelly, the palm parallelly to the ground, it there will be not much effect, only you will feel little bit pressure. But as you change little bit angle upwards of your palm, you will feel that your palm is raising up, right? Let me demonstrate you here. For example, आप ऐसे ऐसे पकड़ा है, आप उसको थोड़ा सा टिल्ट करते हो तो क्या होता है, आपका palm ऊपर रेज होना होता है, right? What happens? It tries to up. But if you try to change the angle of attack too much, like this is very much, right? What happens? Your palm goes backward, drag बढ़ जाता है आपका, right? So this is what the difference what you have. Okay. So takeoff, it is a phase of flight in which the aircraft goes through the transition from moving along the ground to flying in air using a starting on a runway. For balloon, helicopters, or fixed wing aircraft, no runway is needed because they are doing vertically takeoff. जैसे drones है हमारे vertically takeoff लेते हैं directly, right? Flight is the force in which objects moves through an atmosphere without contact with the surface. This can be achieved by generating aerodynamics lift associated with the propulsive thrust. Means what? When the aeroplane is in flight, how does the flight happens? Continuously flight. अगर आप इंजन बंद कर दोगे तो आपकी फ्लाइट चल सकती है? Will your aeroplane fly? No, right?
No.
So certain, since it is an aeroplane, since it's aerodynamically designed, what will happen? It will glide. It will glide. Your aeroplane will fly. It will see, if you stop the engines, all the engines you stop, your aeroplane will not fall down immediately. It will glide. It will keep on gliding because there is a some motion is there, angle is there. Your wings are been designed to glide on the air, in the air. Okay, so it certain extent तक वो glide होके फिर वो नीचे नीचे आएगा, धीरे 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 it will descend. Okay, that's how you can control. So controlling the surface, even आपके engines fail हो गए, engine stopped working, you still can fly your aeroplane and safely land to some safe place. You can land on a highway. You can land it on some ground surface, plain ground surface, or you can land it on the water also. Safely you can land. But whereas in drone, अगर आपकी एक मोटर बंद पड़ गई, your drone will crash down because drones are not designed in a aerodynamics way. The drone are following drone are not flying aerodynamically. They are flying because of Newton's third law of motion. It is pushing the air down and it is climbing up. So till the motor घूम रहा है, it will manage on its own. The moment you stop the motor, it will drop down. Clear? Understanding? Clear understanding of the drone flying?
Yes.
Okay. The last topic is landing. Landing is the last part of the flight where airborne aircraft returns to the ground. When the flying object returns to ground, the process may also called as touchdown. हम लोग बोलते हैं ना touchdown हो गया, aeroplane has touched down, safely touched down and all that. Similarly, drone में भी once you have completed your mission, you can always touch down your drone down, vertically down. Okay, so let's see what are the maneuvers and turns and circuit patterns. So normally you have four flights maneuvers, what we normally say. One is the straight and the level flight. So that means your aeroplane is take off, going straight and level flight. So आपने देखा रहेगा, like those people who have flown in the aeroplane, you will see that your aeroplane will take off from Mumbai airport. It will climb some to 20,000 feet, and then it will keep on going at that flight, at that level. There will be no change in the height. That is called as a level flight. That is the time when the air hostess will be serving you the food and water and all the things. Okay, when it is coming towards the airport, near the airport, like let's say it's going to Delhi, as it returns to the Delhi, reaches the Delhi airport, you will be instructed that you need to return back to your seats and all these things. Air hostess will keep all those tray, tables, everything inside. They will lock everything and then they will sit. That is the time when they will say descent. So your aeroplane will start descending. So almost 10-20 kilometers away from the aircraft, from the airport, the aeroplane will start descending, descending, descending. So that is the time when they are actually consuming very less fuel. That is the time when it is the skill of the pilot to fly the aeroplane in a such a way that he is consuming very less fuel. He is just gliding क्योंकि वो already 20,000 feet पे ऊपर है. So he just need to align his aeroplane in such a way that it aligns to the proper runway. Okay, so he will communicate to ATC that I am so and so airplane and I'm requesting to permission to the land and all that things. So all that communications will be happening, and then once he gets the proper acknowledgement and all the things, he will land his aeroplane. So that is what we call as descent phase. As we are flying, we sometimes needs to climb, like sometimes due to some turbulence or some issues we need to climb. So what we will ask ATC that I am encountering some turbulence into that and requesting to give me the next flight level. So then probably looking at the radar and the weather conditions, ATC will say, okay, so and so aircraft, please climb from 20,000 to 25,000 or maybe to 30,000 flight. Okay, so that is the time when they would say. Or sometimes you are encountered a lot of turbulence and it's a big cloud and all the things is there. So you will request ATC to give the separate path. So that time you may have to turn right or turn left and correct your course of flight plan accordingly, and then come back to the original flight path after flying certain distance or away from that turbulent area and all that things. So there are four flights maneuvers. One is the straight and the level flight. Then there are turns, left turn, right turn. That is where we actually use elevators. Okay, and then we have climbs. Okay, climbs will actually sorry, not elevators for the turns. Turns is radar. Yaw motions. Okay, we are changing the headings, and then the climbs where we'll be using elevators. So that is pitch up and pitch down, and again descent is also where the pitch down motion will happen and your aeroplane will descend down. Okay, so clear on the maneuvers, turns and circuit patterns. So normally you will fly from the runway, and then you will circle the runway and all the things. Okay, so this is how the circuit pattern will look. So you will take off from the runway 23. You will take off. You will take a circle. You go back. And this. So this type of flight is not generally used. These are used only for training and for the military purposes, where you are actually training yourself. So in normal, what we called civil airlines, this part, the final leg place happens on a different runway. आप मुंबई एयरपोर्ट से एरोप्लेन उड़ा के घूम के वापस मुंबई एयरपोर्ट पे लैंड नहीं करोगे ना सिविल एयरलाइंस. इट इज अ वेस्टेज ऑफ फ्यूल एंड वेस्टेज ऑफ रिसोर्सेस, राइट. तो नॉर्मली आपका ये जो सर्किट पैटर्न विल बी हैपनिंग ऑन टू डिफरेंट रनवेज. तो आपका टेक ऑफ मुंबई एयरपोर्ट पे हुआ, आप टेक टर्न किया, जो भी किया, you will keep on flying, you will reach Delhi airport, and this part of the airport will be Delhi airport. So your landing or touchdown will happen at the Delhi airport. This type of flying will happen only at a small general aviation for airfield or multiple. जब आप ट्रेनिंग कर रहे हो, है ना, जैसे हमारे धुले एयरपोर्ट पे स्टूडेंट्स फ्लाई करते हैं, तो दे टेक ऑफ करते हैं, एक चक्कर लगा के आते हैं धुले सिटी का, एंड देन दे डाउन अगेन. Okay, so that's how they try learning, like take off or landing अगर सीखना है तो they will try to do like this. Okay, so with that we come to end of the topic called basic principles of flight. Any questions you have? So only couple of things before I take your questions. I just tell you only couple of things you need to understand and remember. One is the airfoil, chord line, then your motions, that is yaw, roll and pitch and throttle, and the control surfaces, that is your elevators, ailerons and radars. Okay, there are additional control surfaces like as I was talking about earlier. Okay, yeah. There are additionals like slats, spoilers, flaps, then you have radar में भी दो होते हैं, primary radar, secondary radar, primary elevator, secondary radar. So they are nothing but they are just combination of extra control surfaces. जैसे आप फ्लैप्स क्या करते हैं, आपका विंग का शेप जो है वो एक्सटेंड करता है, बड़ा करता है. So the more the wing surface you have, the more better lift you get it. बट एक बार आप लिफ्ट हो गए तो आपको इतना बड़ा सरफेस की जरूरत नहीं है, बिकॉज देन यू जस्ट हैव टू मेंटेन द फ्लाइट लेवल. आप लैंड कर रहे हो, तो क्या हो रहा है, आपको ड्रैग बढ़ाना है. तो क्या करता है, आपको जो फ्लैप्स का जो पोर्शन है वो जो ऐसे शेप में है ना, वो ऐसे अपोजिट डायरेक्शन में जाता है, वो ऐसे नीचे रहता है, वो ऐसे ऊपर आ जाता है सीधा. तो क्या होगा, एयर को प्रिवेंट कर रहा है, ड्रैग क्रिएट कर रहा है. सो आपका एरोप्लेन जब लैंड होता है ना, तो आप स्पॉयलर्स ऑन करते हो, ओके, और स्लैट्स ऑन करते हो, तो क्या होता है, आपका जो सरफेस एरिया है वो ब्रेक हो जाता है. ओके, यू विल नॉट एबल टू जनरेट दैट मच प्रेशर. ओके, सो क्या होगा, आपका क्या होगा, ड्रैग बढ़ जाएगा, तो क्या होगा, एरोप्लेन स्लो डाउन हो जाएगा. Okay, so there are additional surface controls, or these are additional things which are being there into the bigger airplanes. You will not see in a smaller airplane so many control surfaces. In smaller airplanes, you will see only major or primary flight controls, that is ailerons, elevators, and radars. Okay, so remember, on the tail, that is your horizontal stabilizer, you will have elevators. On the vertical stabilizers, you have radars. On the wings, you have ailerons. So these three things you should remember. Okay, I'm getting a call from office, just a minute. Team, just give me some time. Okay, anyway, we are moving to the next topic. Just you can take a bio break if required for 5 minutes.